Thank you all for joining us today. So this talk is going to be about when design meets data, using data mesh for a consumer and business-driven data strategy. I would like to start off with a quick introduction. My name is Deepthi. I'm the lead business analyst with the TechOps data program team, where we are trying to make Thoughtworks a data-driven company. So that's our ambitious mission for a couple of years now. And
and hi everybody. My name is Ammara and Gafoor. I'm also lead business analyst with Thoughtworks, and I'm primarily dealing with data projects in the healthcare sector.
Right, thanks for that, Ammara. Moving on, this is going to be the agenda for this talk. We'll start off with what do we mean by data projects, right? What do we consider as data projects? And then we'll talk about what are the current approaches when we see that we've observed with our clients and some of the teams when they say data projects. When it's running on the ground, what are the current approaches we've seen? What are some of the challenges that we've observed with this above said approach? Our recommendation on how you can overcome or sidestep those challenges, and then some key takeaways we think would be useful for you when you're thinking about your data strategy in your own organization. So with that, let's get started. So what do you mean by data projects, right? What comes to your mind when you think about data projects? It might be probably data pipelines. Probably you think of creating a data platform. And then you also think about BI tools, etc., right? So all of those are right answers. Except with one premise that everything here starts with a particular business need, which means that when we say a data project, the goal would be to enable a user from point A, wherein they have to make a particular decision or take an action and then move to point B, so that they've been able to make that decision, or they would be able to take an action using data, right? So this seems pretty simple and like common sense, right? But please bear with me as to why this is a focal point for us as we move forward in this talk. So given this objective or goal, any component or any framework, any implementation that you do in your organization would be to support this above said goal. For example, you might be building data pipelines, which is to pull data from a source and then put it to a destination. Why? Because you want to serve that data so that it can be used by your users. And you have some value that is coming out of them so that they can make a decision or an action. Or it might be that you are running machine learning algorithms or making predictive analysis, again, on top of this raw data. Why? So that, again, you will be enabling your users to, again, make a decision or take an action. So with this in mind, what are some of the approaches that we've seen to achieve this business goal or objective? When it comes to the implementation part, we've seen it taking another turn, which goes something like this, right? So while that is our goal, when we try to implement, the point is we would try and collect our data and make it readily available so that we can do some analysis or modeling on top of it, therefore enabling data-driven decision-making. In very easy terms, what it means is here is some data, see what insights you can build out of it, right? And let's see what happens with that approach. What does that actually mean and how this approach is a bit different? So you have data which lies within your organization in different siloed systems. And then you would want to collect your data from different systems, probably run pipelines, collect it from the source, put it to a particular destination, maybe a data lake or a data platform. And then what you would try to do on top of that is probably do some analysis, run some models, do some experiments so that you can create some insights. And then ideally, what would happen is some of these insights, they might lead to some decisions by the business users, which then again flows in as an action that they can take based out of these outcomes from the previous steps. And as you can see, this is not going to be sequential. It's going to be a cyclical loop. But what we've seen is the focus is more on the data and the insights part, wherein you have a lot of resources and investment pouring into collecting the data, processing it, cleaning it up, and then creating some insights out of it, rather than the decisions and the actions part, right? So this is one common approach that we've seen, and this is what we would like to call as a data producer approach, because the focus lies with the data producers in this case. So this is from a data strategy perspective, right? When you're operationalizing a data strategy from a 10,000 feet view, for example, what happens if you go even one level deeper? When you look at the grassroots level, what actually happens in your teams? To make this ecosystem work, you have several different parts that has to be in sync with each other to enable your business user or to create enterprise value. And then again, as you can see, it starts with the data producers in mind. So you have the data producers on the left and your users on the right, right? Like this is the approach that we see. And then when you get into each particular box there, you see that the people who are actually working with this data are going to be different in each of these phases. Your users are going to be different, and the nature of the work that they do is different, and their data maturity levels are going to be different. For example, you start with data producers who are the owners of data. Typically, how you can define this persona is they understand what is the data that they're collecting because they are closely associated with the system and the domain that they're working with. And then they collect the data, they store it in the system. And then what happens is this data is now pushed into your data platform. Probably you'll build data pipelines, etc. And there, again, most of the teams, you have a dedicated data engineering team. Why they come in is because they specialize in a certain set of skills in order to be able to play this data, which can be used by others later down in the pipeline. So they probably convert your data and make sure it follows some SLAs, they publish it into the data platform, and then they make it ready for the next steps, which then passes on to your data analysts, your scientists, data scientists, who then try to understand this data, see if this data is enough for making insights. They run some experiments on top of it. They try to understand the causalities, make some predictions, etc. They do analysis and visualization. And then it leads on to your actual users of the data, which might be business users. They might be using these analysis through, say, BI dashboards, etc. reports. It might be other users in the same domain, etc. So this is the entire flow, right? This is what it looks like. And with this ecosystem and goal in mind, what are some of the challenges that we've seen with this particular approach? As you can imagine, it's not going to be simple. And we'll also tell you in two particular lens, right? One is your customer and your user experience lens in this whole ecosystem. And we'll start with these phases again. And this time we'll go from the end objective or the goal, because that's why we are even running this whole project, right? So what happens is, for your business users, what is the problem that they face with this approach? Typically, you see that, as I mentioned before, the decision and the action loop never gets closed, which means that if the business user wants to take an action or make a decision, and has to be really nimble about it based on the sensitivity of time and the data flowing in, probably requirements are changing, and even their own understanding has evolved over time. Whatever insight they thought earlier, probably it might not be correct. So they've asked for new insights and new decisions to be made. The lead time that it actually takes for this whole process to be done is actually very time consuming. And then for them, it just means, please give me a dashboard which is actionable, or a report which I can actually use to take some critical decisions. And if you look back, when you try to do understand the crumbs of where the problem might be, you go one step back, and then you understand that there is a different set of users who are working with the data to make this possible, and they are your data analysts or your ML or AI experts, your data scientists, and they understand the data well, but then they understand that, you know what, the data that has come in, it's probably not in the right way. Probably I do not have all the data that I need, or it's not clean, and these experiments are taking longer than expected because it has taken me some time to actually understand the data itself. And then if you go even one step back, what happens is you have your data engineering teams who are all in the midst of everything, and then they don't actually understand the data. Why? Because they're not close to the domain. They're not close to the business either. And hence their role in the whole system is just for their special skills. They just tend to pull in data accommodate certain SLAs, and they'll have a huge tech backlog, and they have to cater to multiple teams to publish data to them. And given that this is the understanding, then we go one step back, which is your data producers or your owners who say that I have my own priorities to run my own system. I'm making probably some transactional system. I want to make sure my business actually runs. I do not have time to work on data insights, for example. And they are very distant from the whole problem here. So if you look at it, right, in this complicated ecosystem, you have multiple data touch points, which means that it is very fragmented and siloed. And because of this, the stimulus and response for each box here, it's going to be very tricky. It also means that this siloed experience will cause friction in every step along the way, because users in their own boxes are trying to understand the data that is coming in. They're trying to trust the data and then make it go to the next step. So each of them have their own problems. And at the end of it all, if you go again one step back, what is the major problem that it comes out of it? Imagine you're the business manager or the sponsor who's actually running this in your organization. For you, you've invested a lot of time, resources, and investments in your data project. You've put people, you've put specialized skills into it, you've built data pipelines, but then how do you know if any of this data project is actually successful? Has it been, does it even mean that you've been able to take some actions? Has it been a right return on investment? And all of these questions pop up, which means you cannot prove the value of the data projects that you're trying to imbibe, right? So this gives us the challenges of the approach that we have seen with the data producer approach. And with that, I would like to actually check with you folks on the call here, which of your teams face this problem today? I'm just going to run a quick poll. Sabrina, I think, can I take some help in running the poll here?
I've started the poll. It should be visible right now for people.
Okay, thanks, Ammara. Right. Okay. So with that, I think I would, with that thought and the poll that is running, I would like to hand it over to Mara to talk about the poll results and take you through what we think is the recommended approach that you should be taking, right? Over to you, Ammara.
Thanks, Deepthi. The results are like super interesting. It seems like majority of us are facing almost all of the issues, at least that's what I'm able to observe. And quite honestly, as I work with a lot of different teams with a lot of these problems, and as we go into this and we see the same problems repeating over and over again, we asked ourselves, there must be a better way to do this. And the reason we are here for this talk today, and with the name of the talk as well, what if we actually applied product thinking to our data? Now, product thinking is a concept that has proven so successful that it must have some core elements that could be applied to data as well. And before we actually see how that would work for data, just a second, I would like to do a quick recap what it means, what are the core principles of product thinking, right? With product thinking, we are focusing on what is the outcome we want to achieve. We are talking about who are the users of our product. And very importantly, we are also focusing on how will they actually use the solution. With product thinking, we use a concept called as hypothesis-driven development, where the emphasis is on failing fast, on learning and continuously improving. Fundamentally, with product thinking, there's also the concept of ownership. In a nutshell, the product thinking, what it produces or what it propagates is that with product thinking, it all starts with the user. And now that we know we've quickly recapped what are the fundamental principles of product thinking, let's see how we could possibly apply that to data. So with these principles, when we try to build a roadmap, just a second. Yeah, so when we tried to build a roadmap, we came up with a 4-step approach. One was about aligning to business goals, defining hypothesis, defining your data products, and then choosing which data products to build. Here I introduced to you a concept called as data products. Now this is something that is kind of new. And what does that really mean? So a data product. A data product is a meaningful collection of data that basically is serving a particular purpose, right? Very fundamentally, it's about you're basically collecting data from certain sources and then you're providing data in certain formats. But what makes a data product different is that it has a fundamental use case. It has a goal, and this goal of what the data is trying to achieve. It also has clearly defined SLAs. And primarily, it also takes into consideration this concept of ownership. So who is your owner? With this in mind of what a data product is, let's try and see how we can apply that into your data product roadmap. So we have a step 1. Yeah. So we took this to some of our businesses, and here I would like to show you an example of a mobility company that basically had infrastructure like trains and buses and cars. And one of their goals and visions was basically to increase the profit margin. One of the ways they tried to do this was by increasing the infrastructure capacity by 40%. Now, increasing profit, this is a goal that a lot of you might be familiar with. Many organizations have this as a common goal. And whatever is your business goal, you can use multiple different methodologies to actually reach this goal. You could use OKRs, or you could use like a lean value tree. Irrespective, the first step with product thinking always is to align to a certain business goal. And that's what we did as well. Step 2 is basically defining a hypothesis, right? Ooh, I'm struggling a little bit with the control of the slides, but I'm hoping I get it now. Cool. So the step 2 is about defining your hypothesis. The hypothesis is, now that I have a particular goal, how can I actually achieve this goal? So for this particular company that we worked for, one of the ways they thought, how could we achieve our infrastructure capacity goal would be, for example, to reduce your train outages or maybe make the track maintenance better. So this is like a hypothesis, right? And then when you're brainstorming and you choose a particular hypothesis, then you see, okay, if I want to basically optimize the track maintenance, how can I possibly achieve that? Maybe if I forecast the track maintenance needs, then I could contribute to this particular goal. So now I have an analytical use case, which will help me contribute towards my goal, which helps me contribute to my business objective. With this in mind, I come to my step 3, which is basically about defining my data products. So far, I think this is quite common. This is a general data project. Nothing is so far different. This is the first time we are entering into a new category or new territory where we are trying to start defining this data product. And we are saying, in order to achieve this particular analytical use case, that means I want to have forecasting of my track maintenance needs, I'm introducing a concept called as my data product here. And the name of my data product is track. So what's so different about track? Track is basically has a complete use case about it. Track is all the data that is necessary that has a specific goal of basically forecasting your track maintenance needs. That means from my ecosystem of data that exists in my company, and that could be transactional systems like SAP, it could be regular databases like Oracle, or it could even be your data present in your cloud. I'm pulling all the data necessary to my data product track in order to satisfy a particular goal. So this data product today exists for a specific goal. The second part of my data product is that it's now trustworthy. It very specifically says and it defines what SLAs it will satisfy. For example, my data will be refreshed once a day, or it will be clean to 50%, or you can rely on it for 70%. It has very clearly and distinctly defined SLAs. It also is very clear about how it will provide its data. It could be in terms of dashboards. It could be in terms of AWS buckets. It could be in terms of an API. What the data product is doing as a first snapshot view is that it's providing transparency about what it is and what it will give to its users. The beauty of data products starts evolving when we start repeating this process. Imagine you have multiple such business goals and multiple such hypotheses. And with each hypothesis, you start understanding, I need multiple such data products. Some of these data products you identify, that means the data you need for these hypotheses are new, like you identify new data products. And sometimes you identify that it's the same data product that could possibly grow. With our example of track, for example, initially it was focusing only on maintenance data, but if I have, say, a hypothesis where I also need track incidence data, I already know I have a track data product, and now I can just grow it, right? So I'm now, instead of taking all the data relevant to track, I now pull the data specific only to maintenance and to incidences. And so the data product now has two specific use cases. So it's a use case driven approach of building your data. Once I've identified multiple such data products, I could start grouping them. Logically, they start making sense. Imagine all the data products that are relevant to, say, the domain train, or all the data products which could be relevant to a different context, like, say, for example, engagement. These could be grouped together. And this grouping is basically what we call as a domain. It's a logical bounded context. The advantage of grouping it like this is that you're putting things that are relevant. You're putting data and teams and data products that are relevant to each other under one logical bounded context. And that is the concept of a domain. How does it all fit together now? We had a hypothesis, we had a goal. Now we have identified the data products needed to achieve these goals. So for example, we started with optimizing the track performance, maintenance, and we needed only track as a data product to hit this goal. Maybe there's a different goal and I need a combination of two other data products. The interesting part is that imagine I have a third goal and I could use a combination of data products, one from one domain, the train domain, and one from a different domain. And from a 1,000 feet perspective right now, you can actually start playing with your data products. These are like your Lego items where you can pick and choose, and you can start looking, if I had data from here and if I had data from this domain, what are the different hypotheses that I could possibly satisfy? And data products is one of this way or this approach that lets you achieve that. This also now makes it so much more easier to start prioritizing. You start applying principles of product prioritization. What is my immediate need? Where does it have the highest value for my business? How many people will be impacted? How much will they be impacted? And you can start grouping your data products based on immediate need, midterm need, and low need. You can also use your product principles of validating your or experimenting with your data products and experimenting with your hypothesis even before you build these data products. For example, I make a hypothesis that if I can forecast the track maintenance needs, I can increase my capacity. So let's just try and forecast it and see whether it actually the hypothesis holds true or not. And if it holds true, then invest that amount of time, energy, and money to go ahead and build the right data product. And so you are down to prioritizing just the way you would prioritize products in a product world. You can now prioritize data products in a data world. And so in the beginning, when Deepthi spoke to you about a data producer approach, the focus was about data and where the data is sitting. The second step was about where a team that is like a bottleneck that is responsible for processing that data. And then finally, you are actually having your data scientists and your ML experts working on BI solutions, and then the use cases in the very end with the data producer approach. This is the traditional approach that we commonly observe across all data projects. What we recommend to you today is what we call as the data consumer approach. The data consumer approach is where we are talking about data products, and we are starting with the use cases and working backwards. These are the use cases that we have, the business use goals that we have. What is the hypothesis that we need for it? What are the data products that are required for it? And therefore, what is the data we need to pull for it? And not only is it about vertically slicing it and making sure we are starting with the business use case, but also grouping it in what we call as these logical bounded contexts called as domains, to make sure there is ownership and overview of where we want to pull this data from and who will give it to us and who is responsible for it. In a nutshell, this approach is called as the data mesh. And the data mesh has four foundational principles: data as a product, domain ownership, federated computational governance, and self-serve data platform. In today's talk, we spoke mostly only about data as a product and domain ownership. Governance and self-serve data platform is at the second and the third and the fourth aspects of the data mesh, which are not under it's an extension of the data mesh and basically requires an entire talk by itself. But I ask you today to focus maybe on data as a product and on domain ownership. And I encourage you to actually go look up this concept called as data mesh, which also explains the computational governance and the self-serve data platform. Because as you can imagine, to make this consumer-driven approach happen, it requires all these four principles in a nutshell together. So how does this approach really help? We spoke about the different problems that exist. We know about data producers and owners who have their own priorities. This approach practically helps it by saying you're putting the producers and the consumers of the data as part of the same domain. So people who understand the data are also responsible for all the analytical experiments. They're part of the same domain and the same goals, and therefore the priorities are the same. The data engineering teams, who were foundationally like the bottleneck in between, that was serving to many different teams, now actually start understanding the data, because we are talking about cross-functional teams. They're part of the same domain. There are data engineers that are part of the domain rather than being one team outside. And we are addressing that problem point. The data analysts and the experts, the data that is coming is not clean. The data experiments are basically useless. An important part here is that by clearly defining SLAs, you're creating transparency of what even a data scientist can expect. The problem is not just that the data is not clean. The problem is that usually data scientists don't know what to expect. And so if as a data product, you're telling them, hey, in the first version of my data product, you can expect only 50% of clean data, then the experiments that they design will be based on that, and they know what to expect. And this is the beauty of making sure transparency and SLAs. Finally, business users. Why does this take such a long time? Just give me a dashboard. The business users are now part of the prioritization process. They're part of setting those domain goals, and they know which data products are helping achieve what goals, and therefore they know how a change request will work. They are part of it. From a higher view up, the business problem that we had before, you know how it was never clear whether a project is really successful or not. There was never a definition of success before. Now there's a definition of success. You have a goal. You know exactly the estimated, the projected benefit of hitting that goal. Imagine, will you hit this infrastructure capacity? What is the money benefit you can get out of it, right? And then you know the cost of it that will be there for building those particular data products, for the teams to support those data products, and you can do a cost benefit analysis. So is this a worthy investment to make? Yes or no? And at the end of it, did it pay off? Yes or no? And finally, we get down to data projects that have a binary answer.
Today, you learned a lot of new concepts, and you've seen the 4 different steps of actually making this happen. But go back to your own projects, and we've asked you to have 3 main takeaways. Ask yourself, where is your focus on your data projects? Are you focusing on tools? Are you focusing on things like Tableau? Are you focusing on things like Redshift or AWS? Are you talking about tools and sources on catalogs? Are you focusing on these things? Or are you focusing on designing your business strategy? Are you making sure you're focusing on the business and holding it hand to hand with your data strategy? Take with you the product checklist. Go back to your data projects today and see, are you applying this product checklist? And are you able to make this connection? And are you doing hypothesis-driven development? And is there ownership? And if not, see what you can do to bridge that gap. And finally, I would like to leave with this thought, with the 3rd takeaway: complete the cycle. It starts with data, it goes towards insights. Make sure that the decisions and the actions, the main problem statements, which are currently not being addressed, start getting addressed. Your insights have to lead towards decisions. Decisions have to lead towards actions. And remember, this is a cycle. If your actions are not reflected in your data, then your data project is not a data project. With that, I open the floor now for any questions that you may have, and thank you for listening.
Deepthi, Ammara, thank you very, very much for an amazing talk. And Deepthi, your connection was a little bit unstable at some points, and I was a little bit worried that it would cut off and that I would have to pull out one of the 3 jokes that I wrote down to bridge any technical issues. So I think we were lucky and it didn't happen. Now, there are a few questions. One that Andrew has asked that I would like to read to you. So he said that he was really enjoying the data mesh talk, and he also writes, does this bring in data engineers into the domain train in order to provide this product? How does this tend to work at a resources level, i.e. splitting the German team between all data products?
This is a really good question and a very practical one, in fact. How we are doing it currently is that it's not a one-to-one connection. That does not mean it's one data engineer per data product or one team per data product as such. Usually we like to establish cross-functional teams, and data engineers are part of these cross-functional teams, and they're responsible for maybe one data product or could be more data products. Mm-hmm. And they are usually part of a domain. So think of a domain as a slightly higher or bigger context. And inside this domain, you could have 3, 4, 5 cross-functional teams. And each cross-functional team has 1, 2, 3 data engineers in it as well.
Yeah, and that's really an interesting question. And this is where the principles of data mesh get applied, right? Probably one of the things that we didn't talk about, but if you think about the self-serve data platform, the idea is that we can abstract all of these complexities that data engineers have to deal with, and then you build a self-serve platform so that the teams who are actually working on it, they can be generalists, right? And they would be able to use the functionalities of the self-serve platform rather than continuing to rely upon data engineers. So this way you would be, again, abstracting that complexity out. You're just making it available to everyone. You're democratizing data, and it's just smoothing it again. This is in addition to making data engineering teams, imbibing that data engineering capability as part of each cross-functional team that Ammara just mentioned.
Great, thank you, Deepthi. And there's actually another question from Christian that also kind of touches on the team aspect. And he says also, yeah, thanks for sharing an excellent presentation. And he asks, will the data owning team also be creating and owning the data product, or will that be separate teams?
So this has 2 layers. This question has 2 layers to it. Here it is important to understand that there are two layers of data. One is called as transactional data, which is basically your day-to-day work. And then the second part of it is called as analytical data plane. The analytical data plane is usually data that is used for such hypothesis use cases. You're trying to derive some insight and it's not your day-to-day work. Ideally, an analytical team is responsible for building these data products, and they are first level pulling this data from the transactional data, and then all the analytical use cases come from it, and the data products are sitting inside this plane. So if the data is just for your day-to-day work, then that would be a transactional team. They would probably be outside this scope. And it's when it comes to insights-driven organization or using your data for insights, then the owners of that data are also the ones who will actually be part of the maintaining the data products.
Super. Thank you, Ammara. And thinking a little bit more on the question around what is a data product, there was another question that asks, what is the difference between a data asset and a data product?
This is actually the most asked question, and also is the foundation of the very data mesh concept, right? Any collection of data is basically the foundation of a data asset and a data product. What sets a data product apart is, I would say, based on three things. The first thing is based on its clearly defined output ports. Like a data product is characterized by giving its data in multiple different output formats, like by saying it will be available in a dashboard, it will be available on S3, it will be available on as an API. It doesn't matter. When you're clearly saying how the data will be available and multiple ways of accessing this data, that's the first aspect of a data product. The second is that it is an independent unit. It has its own, it's like a quantum. It should have its own infra, have its own code, basically, that it doesn't have any dependency on any other thing, right? So it's independently deployable as one piece of data, and that's a data product. And finally is that it defines these SLAs. It's very clearly, it tells you it has a particular use, it will be updated, it will be refreshed, or how clean will the data be, etc. So there are very, very specifically defined SLAs, and with an owner, there is an owner associated with this. And therefore there is ownership to the data, and that makes it a data product versus a data asset, which is just a collection of data.
Cool. Wow. Thank you, Ammara. That's a really, really great explanation of the difference between the two. There's still quite a few questions, and I think we still have a little bit of time. So if it's okay, I would pose another question to you. That question asks, what incentives do teams have to treat their data as a data product?
Deepthi, I'm happy to take it. If you do you want to take a stab at it, or should I take it?
Yeah, I think I can cover it. So I think when you think of teams, right, like having this, I think the entire data strategy that we talk about is changing the way how an organization looks at data itself, where you bring the ownership back to the domain teams. And when you start with it in that flow, when you start publishing these as data products, it also means that you are making data which is lying, probably dormant, or maybe in some, like the differentiation between data asset and product, right, where you just have data lying there. Instead, you're making it useful. And then when you publish it, it also means that you're reducing the time and effort that it would take for your team to probably cater to any cross-functional domain teams on a repetitive basis. Like, for example, the data product that Ammara just mentioned, once you have a data product defined and published, you can keep adding on to it. It has a clear owner to it. It has a clear purpose for it. And it also knows its own SLAs. You also have an entire life cycle associated with it. So with this in mind, one is you understand how many teams are actually using your data products. When you put it all in a data mesh perspective, you have how many nodes of how many times are these products actually being used? So this becomes one point that this asset is clearly useful to the organization, and this is how it's being used by several other cross-functional teams. And the other is, I think it also looks at the data product ownership perspective, right? Like you have an SLO for each data product. You also have the governance that is associated with it, which makes the entire life cycle much clearer. So I think that would all flow into the entire strategy to make it more incentivized, I would say. Yeah.
Yeah, fascinating. I love the aspect of visibility, that you actually end up knowing who's using your data products. So that's really, really fascinating. And we have one more question, Deepthi and Ammara, from Praveen. I hope I say the name correctly. And the question is the following: how do we run Scrum ceremonies for a data-driven product?
Exactly the way you would run it for a regular Agile project. There is absolutely no difference. You have a goal in mind, you know what your data products you have to build for it. You identify your MVP, you go into your 2-week sprints to deliver it. You have your regular retros, backlog grooming sessions to make it happen. It's absolutely any regular project that you do, the added addition of maybe you have to run some spikes in the beginning to actually understand what it means to pull that data from the identified databases and sources. I would not treat it any differently.
Nice. Super. Thank you. And maybe if I may torture you with one more question, Ammara and Deepthi. I think there's a lot of things, really interesting things that came up. So there was also the question around what kind of projects can use the data mesh approach? Is there a limitation? Can anyone use it?
Absolutely not. There is no limitation, but there is an investment, right? You're looking at organization, 4 levels of changes, right? So businesses that in the future will have a lot of use cases that are coming in really fast, and you need to adapt and use combinations and permutations of data in order to solve these business questions that you need data for. Such organizations should go towards the data mesh. The current lead time between making a business request and actually having that data available in a format to use is anywhere between 6 months to 2 years in most organizations. The bigger the organization, the longer the lead time. This is unacceptable in today's world. So if you see yourself as a business that requires data to survive, then you should be going towards the data mesh.
Wow. So speed to market, getting something out quickly. That's really one of the big benefits that we see here. Super. Then I would say, Ammara, Deepthi, thank you very, very much for an amazing talk. We have many questions and lots of positive feedback. I think you've really struck a chord there. So thank you very much for joining us.